Hello, in this video you will learn how to use Phstat in constructing a group frequency distribution table for a set of quantitative data, and also how to present the data using Phstat in three different common forms of graphs in presenting a group frequency distribution table, such as histogram, frequency polygon, and the Ogive. Now, let's consider this problem, which is taken from the Book of Luhmann. These data represent the record high temperatures in degrees Fahrenheit for each of the 50 states. Construct a group frequency distribution for the data using 7 classes. So in constructing a group frequency distribution table using 7 classes, we start with the range. And the range is equal to the difference between the highest value in the data set and the lowest value in the data set. After finding the range, divide the range by the number of classes, which is equal to 7. And round up the value of the range divided by the number of classes, which is the class twig, so that you can construct the lower limit and upper limit for each class. So these are now the lower limit and the upper limit for each class. So the first, we have 100, 105 up to 130. They are the lower limits of the 7 classes, while 104, 109 to 134 are the upper limits. Now, in constructing the group frequency distribution, we will need the upper limits, the midpoints, and of course, the data. For the upper limits, put it in one column, and then for the midpoints as well. To recall that the midpoint is equal to the sum of the lower limit and the upper limit divided by 2. Thus, 100 plus 104 divided by 2 is equal to 102. Then 105 plus 109 divided by 2 is equal to 107. And continue, use the same formula until you compute all the midpoints for the 7 classes. And then put the data also, or these 50 values, in one column. Now, so to start with the construction, go to add-ins and then press Phstat and choose descriptive statistics, and then go to histogram and polygons. Now, for the variable cell range, highlight this column that contains all the 50 values, including the label. Now, for the bin cell range, highlight the values of the upper limits, again, including the label. And for the midpoints, highlight the midpoints column. Then, check this box because we included the labels of these 3 columns. Check this box also. Check the histogram box, frequency polygon, and the cumulative percentage polygon, are also known as the Ogive. Then click OK. But again, before we finalize the frequency distribution, now before you copy the final frequency distribution table, you have to check the values of the midpoints. So this is the midpoints column. You have to move the values of the midpoint by 1 row upward. So we have to highlight these values, then we cut it, and then move it by 1 row upward, and paste. Thus, this is now the final frequency distribution table, for which we have the highest percentage is 90. The highest percentage is 36%, where it is equivalent to a frequency of 18. Now this is now the histogram of the given frequency distribution table. So we have this where the x-axis reports the midpoints of the classes and the y-axis shows the frequency of the classes. This is the frequency polygon, wherein the x-axis again shows the midpoints of the classes and the y-axis shows the frequency of the 7 classes, while this is the percentage polygon, or also known as the ogive. Now another chart that is commonly used to present the set of data is using the stem and leaf display, or stem and leaf plot. So to construct the stem and leaf plot of this data, again we go to add-ins, choose Phstat, descriptive statistics, and choose stem and leaf display. Highlight these 50 values including the label. Then auto-calculate stem unit, or you may set the stem unit to 10. Thus, this is the stem and leaf plot of the 50 values. Thank you.